Okay, good. Hi everybody, my name is Josh Long, Spring Developer Advocate. How you guys? Wide awake? Close the door. So that's my Twitter, that's my email. If you have questions, feedback, ideas, please take down my email and my Twitter and let me know. I would love to be able to help if I can. I've written now 4 books. I'm working on my 5th about Cloud Foundry. These are a few of them. That one on the right there is SpringRoo. It's free. You can get it from O'Reilly. So springsource.org/Roo. Right, so today we're going to talk about a lot of different things. All of this will start and sort of depend on messaging, right? This talk is about Spring integration and Spring Batch and its application on top of Cloud Foundry. I think it's a very powerful platform to solve problems that we couldn't have otherwise easily solved before, right? The cloud has given us a new freedom to scale out, to go big, right? And I think messaging in particular is a big deal. Being able to convey information over the cloud, being able to use messaging importantly, is a key function of scale. And we're not, you and I, and these people in this room, we are not the first to use cloud messaging, right? Cloud messaging is, he got there first. And if it's good enough for him, then of course cloud messaging is good enough for us. The real kind of cloud messaging we're going to talk about is RabbitMQ, which comes pre-installed in Cloud Foundry. How many of you have heard about Cloud Foundry? I'm wearing the shirt. Do you guys have the shirt? It's good enough if you've used it, but do you have the shirt? You're not as cool as me. I'm kidding. Yeah, well, right. Cloud Foundry, free open source platform as a service from VMware. You can go to cloudfoundry.org and you can get information about the open source project, the code, etc. You can go to cloudfoundry.com to get the free account during beta. Sign up there, get access to it, and so on. And of course, github.com/cloudfoundry to actually look at the code and use it. Once you have it installed, you have a command line tool called VMC. And when you use the command line tool, you can ask the cloud questions. You can say, how many services do I have installed? And this is what I'm doing here. I'm saying VMC services. And it's going to say, hey, you can create a RabbitMQ instance. You can create a Redis or a Postgres or a MongoDB instance, etc. No problems at all, right? It's very easy to do that. So we won't spend too much time on that because we have a lot to cover, frankly. First things first, by the way, before I get too deep into this, how many of you are using Spring integration? Okay. Spring Batch? That guy's my hero. Right on. Okay, so we'll do a quick kind of introduction. We'll look at what Spring integration and Spring Batch look like. There's some code, but it's going to be very conceptual, right? So, and then we'll look at the actual application. Broadly, when we talk about RabbitMQ, we talk about messaging it as a messaging platform between different applications. So you have application A, it wants to send data to application B. It's just like a mailbox. Oh, gracias mil veces, huh? So thirsty. I was just in Sweden. They don't have your weather there. It's cold and horrible. Oh, that's more watery than those other waters. Right then, so application A and application B, I'm trying to connect them, right? Just as if I were trying to send a message through the postal system, yeah? You don't go to your post box every day, put a message in, and then wait for the mailman to come, and then wait for him to deliver it, and then wait for the response, do you? Just, tapping your feet, waiting for the reply to come back at the post box? It'd be terribly inefficient. You wouldn't do that. So that is true in enterprise applications as well. When you get to a large enough scale, you don't want to wait for the transport and conveyance of messages, right? So a very traditional use case. Nowadays, more modern applications are going to be using messaging as an integration layer, as an integration conduit between services. inside of one application. So it's just one application, but you've got a lot of different services, right? So this is the sort of fundamental story. We've talked about this before. I'm sure you've read about this. How many of you are using RabbitMQ and love it? Okay, what about just using it? Let's just start with that. Oh, gosh. Oh, my heart. Hi. I'm watching you. Okay. Right, so RabbitMQ is a messaging platform. It's very interesting. How many of you are using JMS or something like that? Okay, so you understand the idea. RabbitMQ is just like JMS, but without the suck, you know? Much less suck. So first things first, let's talk about integration, right? Going back a bit in the cloud, of course, application integration. And to do that, we need to talk about Spring integration. Spring integration is a framework from SpringSource, the developers of the Spring framework, which I'm sure you're all familiar with. It has a basic premise. One service has to connect to another, and you're not in the same JVM, so you need some sort of intermediate connection, right? And that might be messaging, RabbitMQ. It most often will be, we hope, you know. But it might also be a file system. You have a file that has data, you put it in a folder, somebody else gets it, right? That's a very common application. You might send, I don't know, you might send a fax, who knows, you know, who cares? You might send email, you might send JMS or AMQP messages. There's a lot of different ways of connecting system A and system B. Spring integration makes that stuff easy. And the idea is that you want to stop reinventing the wheel. You can't afford to reinvent the wheel every time. It's easy to sit there and do some sort of horrible code that, you know, sends an email and then somebody reads it on the other side and they print it out and they send it via fax and then somebody enters that into the computer and boom, you have communicated, you know. That does not work. If you do that, you end up getting really complicated, really over-architected systems, yeah? You need to let somebody else do this. And at SpringSource, we think we're pretty good at this, you know? Let us write that horrible code for you, and then you can just use it, right? Hi. Don't worry, we'll wait. Yeah. Okay. That's Jan. That's him right there, yeah? Yeah, okay. Oh, so sad. So in Spring integration, fundamentally, we talk about a producer and a consumer, very much like messaging, right? You have a channel. The channel connects the producer, who's going to send a message, and the consumer. Messages go over the channel. The channel is just like a pipe, yeah? So it's a pipe between one house or another. Just put something in it and it comes out the other side. It allows different kinds of integration, right? You can do point to point, so you can say person 1, person 2, here's a message. Or you can say publish and subscribe. So I send a message and 10 people get it, right? So it's like if I talk to you directly, you and me, versus if I yell into the microphone and I talk to all of you guys. Very different kind of communication mechanism, but it's very common. Once you've sent a message in Spring integration, something has to respond to it. And in fact, you might connect multiple components in Spring integration, right? So you might have 5 components connected together with channels. Component 1, channel, component 2, channel, component 3, channel. This is what it looks like in practice in XML, right? You've got a channel, you have orders on it, you can get a reference to that channel inside of Spring, you can inject it, and when you inject it, you get a message channel object. And then you can send messages into that channel, and then it'll send that message to the component that is waiting for it on the other side. So here, I've got an object to JSON transformer. This is a component, it's an endpoint, right? And it has an input channel, orders, where it's expecting to get order objects. And then it'll do its work, which is to convert that object into JSON. And then once it's done, it'll send the reply out to the output channel, right? So it's a very clean way of saying in and out, right? But I let the Spring integration XML describe how the stuff gets routed. You don't have to write that code yourself. And instead of using object to JSON, I could also do email, or I could write to a database, or I could convert it to something that's written to a file system. Whatever you use, it's always going to look pretty much the same. You'll have a channel, you'll have an input channel, some sort of functionality, then an output channel. So far, so good? Questions? Thoughts? Okay. You just raise your hand if you have any. ideas. So okay, back to application integration in the cloud, right? Let's imagine you're building an e-commerce application, right? We've got this great storefront called Widgets R Us, where we sell widgets, naturally. A widget, by the way, is, I don't know what that means in Spanish. How do you say widget in Spanish? ¿Cómo se dice widget? Widget? Okay, boom. So it's a widget, and we sell them in our storefront because that's what we all do, I'm sure. And our storefront has lots of different services, like we talked about before. The traditional architecture is to deploy all those different services inside of one giant WAR, a monolithic WAR, .war, an archive, a web archive. And that works, and that communication will be intra-VM. It'll be inside the same virtual machine, and it'll be slow. It'll be fast inside the same virtual machine, but it relies on the availability of all those services being there. And of course, they all connect to some sort of database. That's pretty common. How many of you have an application that looks like that? Maybe 2 or 3 services inside of one archive that you deploy in your web container. Easy to scale, sort of, because you can just take the same WAR, and as long as it's stateless, you can put it in some other application server and create as many of those as you like. But it's brittle, right? So if a service is down, then everything else stops. It's also intrinsically Java-centric, right? It's not easy to put a Ruby on Rails application inside of a WAR application, for example. Let's say I've got services, I'm going to deploy them in different WARs, right? So now I've got the front end of the application, a web application, and it's going to connect to these different services. Inventory for managing merchandise and product, and shipping for fulfillment. So I want to make sure that everything gets delivered to the customers, and so on, right? And you might have replicated versions of that. At this point, you introduce RPC. You introduce web services. You say, okay, my web application is going to connect to this service, and it's going to make a web service call. How many of you love SOAP? Web services? Yeah, me either. I'm not I'm sure you have good reasons, but do you really love it? What? You know what?
I said yes for the web services, not for the service.
Oh, okay, yeah, good, yeah, exactly. I'm with you on that. So web services are fine, but they are synchronous, right? You have to wait for the reply. So yeah, works fine if all the services are available, but you still have that same problem of it's fragile. You send a message to a service and the service is down, then what, right? And also, of course, you get the benefits of interoperability. Now you can deploy different versions of different services. So this is an improvement, but there are still some problems, right? So now we move into an asynchronous architecture. Big picture again, right? Now we're saying, instead of waiting for the reply from every web service call in the same thread, I'm going to send a message and then I will forget about it, just like with messaging, right? So this is messaging. Now, my Widgets RS store makes a request of the message broker, and the message broker routes the message to the service. The service will listen for the message, and then as is possible, it will reply. It'll send the message back to the original Widgets RS web application. This has a lot of different benefits, and eventually, of course, all of this, it all goes back to database or whatever, right? You can still do whatever you want to do. But now, you have introduced a buffering, a queue, so that if you have an overload and your service takes a long time to respond, that's okay. It'll be queued, and when the service is able to respond to it, it will. If the service is down because somebody forgot to check the XSD and the SOAP application just completely failed, who cares, right? This will work. You have messaging, you have your services, it's still very fast, etc. That's a good architecture. It's asynchronous. And this is a natural way to build applications, especially in a cloud. From a deployment perspective, your operations people will not like you. They won't like you because there's a lot of different moving pieces here, right? It's not, setting up RabbitMQ is pretty easy. And setting up the code to work this way is pretty easy. Is that you or me? That was you guys, not me. I never leave my phone on. Yeah, totally your fault. Okay, very good. So okay, that code, by the way, all those examples is available there. github.com/spring source/cloud foundry-samples/tree/master/wgrus. We'll look at some of that now, but it's just nice to know that there is actually code you can download and play with, even if I leave you very confused. I hope I won't, but if I do, just go to the code. It's much better. That's what it looks like in terms of, how many of you have studied enterprise application integration? Like Bobby Wolf and Gregor Hope, they wrote this Patterns of Enterprise Application Integration, and they have this great little drawings that look like that. So it's a notation for describing integration flows, and I affectionately refer to them as Gregor-grams, The idea is you have a message comes in over HTTP, then you send it over a Spring integration channel. It goes to the accounting and/or inventory. At some point, that channel sends the message to the aggregator, which will aggregate, it'll collect, and then it'll send it to the content-based router. So based on the kind of message you've got, it'll send it here or there or there. It's like a switch statement in your integration. If it's a good order, it'll go to the shipping container, the endpoint. If it's a bad order, it'll go to the invalid order channel. And then finally, a confirmation email will be sent over SMTP. So all those components, those are all small pieces that you need to support, right? And you want to connect them through channels, but you don't want to write the code as one big thread, right? You want to write it in terms of one service, two service, three service, etc. And then connect them using channels in Spring integration. We see here that the message itself isn't very complicated. You can say it looks like JSON. It's just keys and values, right? So here's the Spring MVC controller for the storefront, right? Somebody makes a request on the storefront, and we have a reference to the message channel from Spring integration, that order channel, right? We can actually build up an order object, create a messaging template from Spring integration, and then just like the JMS template or the AMQP template, we can call convert and send, and we send the order, and of course, it'll get sent over that messaging template, which has a channel, where it'll be eventually routed to the object to JSON converter that we talked about earlier, right? And then from there, it'll get moved on to other pieces in the chain. Very natural, very, very clean. The Spring integration code, more or less, I've hidden some of the code that you would actually need to do this. For example, there's channels and a rabbit template and so on here. But more or less, this code will go through this kind of XML, right? You'll see an object come in from the object to JSON transformer on the order channel. It'll get processed, and then it'll be sent out on the JSON orders channel. Then the claim check will take all those objects that come in from the JSON orders. It'll store them in a database or some sort of storage, and then give an ID. So you have only an ID. You don't have the object anymore, right? It's a claim check. It's like when you leave your luggage at the hotel, and you say they give you a receipt for your luggage. That's called claim check. And then from there, the message goes to the output channel, which is AMQP out. And the AMQP out channel will connect to the AMQP outbound channel adapter, where it will finally actually send a message using AMQP. The Rabbit template there and the orders are Rabbit and AMQP specific parlance, but basically they help route the message correctly in the message broker. Whoa. That guy was following me earlier, I'm sure of it. Like I kept on seeing flashes like, oh God, stroke! Dios mío! But no, it was fine. I do cry in Spanish, by the way. Right, so inventory service now. This is the other side. This is not the front. This is in the background, the service responding to the questions. So now we have to receive the message from AMQP, right? We have to receive the message from the message broker. So we say, okay, I've got an order channel, and I've got an AMQP inbound channel adapter. It's going to sit there and read messages off of the channel for me. And it's going to connect to the Rabbit MQ instance that the Rabbit Connection Factory bean connects to. So I've defined that Rabbit MQ connection factory somewhere else. Doesn't matter for now, right? It can be a Rabbit MQ instance that you've defined in Cloud Foundry. But the point is you've connected to a Rabbit MQ broker, and you received messages on the queue name called orders. And I've even added an advice chain here. I've said, if something goes wrong, keep retrying to receive, right? Finally, I route the message through the orders channel, where it'll go through the claim check and it'll be marshaled back from JSON to an object, right? So now I'm on the other side of the system. I'm in the service itself, but instead of, remember, I got a message. It had just the ID, so I have to do the same thing in reverse. I have to get the object back out of this database storage, right? Once it leaves that chain, now I have a working object. I have an actual full-on order object that I can use in my type system, you know? And then from there, it'll go to the warehouse channel. And the warehouse channel will convert the object and create a string message out of it, and then call orderQ.add. OrderQ.add is a method defined in Java somewhere, right? So you can see I'm actually doing quite a lot of work. I'm actually serializing stuff. I'm converting it from a JSON. First of all, I'm getting the ID, getting the JSON string in the database, taking that JSON string and then converting it to an object. And then I'm going to create a string, and then I'm going to call that orderQ.add method with the result, you know? And then finally I'm going to log it. So that logging information on the bottom there. All of that described in a nice, simple XML file. One more thing, I cheated a little bit in the beginning. I actually showed using the messaging template to send a message on the channel. Turns out you can actually do it even easier. You can build what's called a gateway in Spring integration. So you define an interface like this, and you put annotations on the interface method, and Spring integration will automatically take the parameters for that gateway method and convert them to a message and to message headers, right? So it's just like if I had built a message using the message template myself. But now it's all done for me automatically. And for me to use that, I can just put that XML int : gateway, and I can specify that I want the requests to come in on the orders channel. So all the requests anybody who calls that create customer method, all their requests will go on the right channel that I specified there in the XML. Probably a bad channel name there, but still you get the idea. This is much simpler and it's much cleaner than tying your code to Spring integration. You don't have to actually use the messaging template and all that stuff. It also has the benefit of being the best of both worlds. If you want to build this architecture where you have asynchronous message communication, just like we talked about, but you don't want to write all this messaging code, use the gateway. So the people that are in the storefront, they can still use their regular service. They can call methods just like they would before, but behind the scenes, it gets sent over the channel, and behind the scenes, it gets routed into Spring integration. So it's, you know, good stuff. Okay, next bit. This is for the three of you in the audience that have used Spring Batch. This is actually one of those frameworks. I'm a contributor to both Spring integration and Spring Batch. So I have a fondness for it because, I mean, I don't know. How many of you have written processes where you have code that's sitting there and the only thing it does is it runs in cron and it reads data out of a file system? Raise your hand. Come on, yeah, we all tried it once in college. Don't be ashamed. We've all done this, right? It's hard, ugly code to write, but it has to be done, and the specs, whatever they are, don't solve it, right? There's no good story for that. It seems like every generation reinvents that story. It reinvents that solution. So why bother? Why not just use something that's already packaged and ready to use? Spring Batch has that stuff. It has what you need to be able to read data and then process it and then do something with it, like write it out, right? Quick introduction. Basically, the Department of Social Security, and I think this is in the UK, but it might be in the United States, the Department of Social Security has suffered two major failures. This is 2000, 10 years ago, 12 years ago. Whew, can't believe that. Some people were overpaid. And I know you're thinking, is that a problem? Where's the problem? There's no problem there. But it is a problem for somebody, right? They were overpaid by a lot, which is, you know, in this case it was, I guess, 112,000 people. 112,000 people, that's not so bad. That's a little bit more than we have here. A little bit. That's all because somebody wrote some really bad batch processing code. We don't want that, right? We want somebody to take away that kind of pain for us. How many of you have environments where you have COBOL or CICS, C-I-C-S? Oh, so ugly. I mean, the dirty little secret, and this is between you and me, and I think you guys know this, but in most big companies, in most big financial services companies, there's that first floor, you know? The first floor where the young Java people are, that's us, yeah? And then the second floor where the old fat graybeards doing COBOL are. And they make more money because they know how to speak COBOL, those bastards. Anyway, batch processing is a problem, is my point. It's something you really need to address seriously. Spring Batch is a good way to do it. So here's how the domain model plays out, right? Here's what it looks like when you use Spring Batch. You have a job, and it's like the definition. It's a recipe. You specify the job using XML, and then you specify steps. So step 1, step 2, step 3, step 4. And each step can have data that is specific to the step. It's like a request variable in Spring MVC, right? It's data or session data. It's something that's only alive during that step. So that's called the step scope. When you described this job in your XML, you can then run that job as many times as you want. So you can say, okay, this is my recipe for processing data and loading it into the database. I'm going to run this job every night at midnight, you know, offline, and I'll do this work in a cron or Spring's scheduled annotation or AutoSys or BMC or Quartz or whatever, right? When you run that job, you get a job instance. You can use the job instance now to ask Spring Batch questions. You can say, hey, Spring Batch, how's it going? Anything broken? Anything I should know about? Right? And you can ask it, is anything failed? You can ask it, how much has succeeded, you know? It's very, very useful. This is what your operators want. You go to your operators and say, I have this thing that'll do batch jobs and everything, they'll love you, right? Because this is stuff that's hard code to write otherwise. Specifically, once you start getting into even deeper, you have steps. And the steps have item readers, so they read data, and then they might have a processor, so it's like item reader, processor, and then item writer, right? And the processor is optional. You get a chance if you want to take the data that's been read, do something with it, you know, maybe change the price or whatever. Maybe your company has a sale and all the products in the database need to be changed so that all the prices are now 200% more expensive, which is not, you know, that's a good problem to have. But the point is you have to write that code. So you have an item reader to read everything from the database. Then you have a processor where you go through and you change the price. You know, price times 2, right? And then you write the data back out to the database. You don't want to write this code by yourself, right? So let Spring Batch, which already knows about how to connect to a database, it already knows how to read a million records or a bazillion records from a database, let it do that for you. The only thing that you really have to care about, in this case, is maybe the item processor, since that's a very simple, common case, right? Reading from a database and writing to a database. Spring Batch is good. There's lots of different kinds of item readers and item writers that are provided by Spring Batch for you. So, everybody with me so far? Spring Batch has jobs, jobs have steps, steps have readers, processors, and writers. Yeah? Capiche? Está bien? Okay. Vamos. Let's see. So that's what it looks like. That's the interface, right? There's a whole bunch of different implementations. If you go to Eclipse and hit Control-T, you know, and look at that interface, public interface item reader, you'll see like, you know, a million different implementations. Lots of different ones that you can use. You don't have to write yourself. So if you want to connect using Hibernate, don't do that, by the way. Don't connect with Hibernate. If you have to use Hibernate in Spring Batch, it's gross. But it will work. It's just gross. But JDBC or file systems or XML or, you know, whatever, right? There's lots of different ways to read data. Big data, lots of data, hundreds of thousands of millions of rows, you know? And Spring Batch is very smart. So if you read data from a file and the file is like, you know, 2 million rows, do you have anybody here have a file with 2 million rows? Okay, well, we see, yeah, okay. It's hard to get right? And of course, if you have a bug, then you don't know until like tomorrow. Like, puta que parió, you know, like there's a bug, Oh, you don't want that bug, you know? So, so you don't want that code either. Let that be somebody else's problem, you know? And you know, in our case, it's Spring Batch's problem. So you read the data, comes in one at a time. The implementation will take the data, it'll take each row, and that's T here, and it'll give it to you to work with. It'll give it to the processor. So here's your processor. This is the code you might write, you know? The processor says, okay, item comes in, you get a chance to do whatever you want with it, change the price, do whatever you want, and then you send the result back. You might send another I. It might be I comes in and I goes out, or it can be a different object. There's no requirement, right? And then finally, if you're done with that, you can send it to the item writer if you want. You don't have to, but this is a good place as well. And it'll write out the data in chunks. Notice here that we have void write, and we have a collection, right? Not just one object, but you have like 10 or 100. So you can read in, you know, you can read a file with 100 rows, and you read 10 at a time. And then when you're done processing it, it's going to write them out in chunks. That's how you scale, right? If you want to handle a billion rows, you don't want to open up a transaction and maintain it for a billion writes, you know? You want to do it 10 at a time, and if something goes wrong, then you just retry that 10. But the million that came before it, who cares? They're good, they're safe. Spring Batch will take care of transaction handling if you let it. Spring Batch will take care of all the processing and all that stuff. And it'll give you errors and keep it in the database and everything. So it's a really smart technology. Keeps a lot of information for you. You just write that simple processor. This is what it looks like in XML. Can you guys read that from over there? I was a little worried about this code because I thought they would give me like a football stadium-sized screen. I thought they cared more, but guess not. So I rewrote the code for you guys to be a little bit bigger, but it's not quite big. So this is what we discussed, yeah? You got a job, and then you have steps. I've only got one step because I didn't have a bigger screen. I'm not talking to you, Sergey, but seriously, that screen's adorable. And then you have tasklet, and then you have the chunks, and this is where you describe the reader, processor, and writer, right? You can specify kind of like a workflow. You can say, okay, if this failed, go to this step. If it didn't, go to this step, you know? That's what I'm doing here. I've got next on, you know, different kinds of behaviors based on what happened in each step. Okay, so we all in agreement that's pretty cool, right? Yeah, me too. The problem is it's slow. It's one by one by one by, I mean, it'll do chunks. It'll do 10 at a time. But still, if you have 1 million records and you're writing to Oracle, and we all know how slow Oracle is, it'll be a week, you know? You can go faster, especially if there's no relationship between the last record and the first one. If the last record that you're writing is different from the first one, but it doesn't matter if the last one gets to the database first, why not split the work up, right? Spring Batch makes it easy for you to specify a thread pool. So use the thread pool, and you can run the jobs on multiple threads, and it will restart this. If somebody pulls the power on the machine, Spring Batch knows, okay, we have this much done. We have 60%, yeah? But we're not done yet. But it's, you know, this is this is input and output intensive kind of stuff. You want to take advantage of the extra horsepower that we've got, you know? And I think the cloud, in particular, Cloud Foundry, makes a very, very intriguing use case here, right? We have the ability to create as many computers as we need and divide the work over a cluster, and then when we're done, we just scale back down, right? And it would be nice if there was some way to do this in Spring Batch, some way to partition. Well, it turns out there's a partition handler in Spring Batch. So what happens is you have job, just like before. Jobs have steps, but one step in particular is a partitioned step. So that you go to the step, and then the step takes the input, and it sends it out over other members of the cluster to do the work. Okay, so now you've got divide and conquer, yeah? And you're asking me, what's the right way to, what's the right fabric, the right technology to divide that work? Well, by default, Spring Integration provides a partition handler that works with Spring Integration. Spring Batch provides a partition handler that works with Spring Integration. So the master sends a message over channels, and then from there you can be on the other computer, another node, with RabbitMQ, you get the message, do the work, and then send the result back, right? Now you have instant scalability. Who needs Hadoop, right? We have this. Okay, so now we're kind of at the end of this thing, man. We've gotten from here to there. You have been very patient. Now I want to be able to answer any questions if you have them. If you have feedback, no tomatoes. I don't know where you guys bring those tomatoes from, but that's not okay.